Hello everyone, myself Rishabh. Today I'll be explaining out of order execution in a processor. So it is executing the instruction other than the program order. Now the next question comes, why do we need out of order execution? So as shown here, there are three instructions where I2 has a dependency on I1 with a read after write dependency. So for I2 to execute, I1 has to be completed, which will create a stall in the pipeline when we do in order execution. But in case of out of order, this I3 can be executed before I2. That will help improving the throughput of the processor. Now, next, I'll be explaining how the out of order execution takes place inside the processor. Before that, I'll be explaining what are the elements present here. First one is a instruction queue. This holds all the instructions in the program order. Next, we have unified reservation station. So when instruction is fetched from the instruction queue, it waits in the unified reservation station for the execution unit to be available. So now we have the execution unit. These are the actual ALUs which executes the instruction. Now next comes the register allocation table. The register allocation table is used for the purpose of register renaming to avoid false dependencies like write after write or write after read. Now, next we have a reorder buffer. The reorder buffer is used to commit the instruction in the register file in order. This is done to handle the exceptions like branch prediction or divide by zero. This reorder buffer has two pointers. First one is a issue pointer. This acts like a write pointer. When an instruction is fetched from the instruction queue, the issue pointer gets updated after the entry, and commit pointer is like read pointer. So when the data is written back into the register, then the commit pointer increments. So this execution happens in a four step as shown here. So I will explain each of the steps. First one is the issue step. Issue step, here the instruction is issued from the instruction queue to the reservation station. So it's a add operation. The destination is R1. Then the first operand is R2. The other operand is a value 0.2. Now once this instruction is fetched, it gets an entry in the ROB, and the same ROB entry is updated in the register allocation table. Let's call it ROB1, and the issue pointer moves to the next stage. Now the second instruction is issued. This is the multiply instruction. Here our destination is R4. Here the first operand is R1, and but R1 has a data dependency here. So it has to wait for the results from ROB1, and the second operand is R3. So now the next issue stage is done, and this will also get a ROB entry here, and similarly this will be updated with ROB2. Now the next stage is dispatch. So here add instruction can dispatch to the add execution unit since it is available, and once execution is done, it broadcasts the result in the bus. That is the broadcast stage. Seeing this broadcast, the ROB samples the value. The ROB will sample the result of the execution with the value R2 plus 0.2, and the reservation station will also sample, and this value will get updated to R2 plus 0.2. Now since this instruction is completed, the done bit will be set, and once done bit is set, then the value of R1 can be committed to the register file. So the value of R1 will be committed in the register file, and this commit pointer will move here, and this ROB entry will be cleared. Similarly, the now R1 contains the register file contains the latest value of R1. So rat entry will also be updated with the value R1. So this is the way the execution takes place for the instruction. Thank you.